If the engineers of Burj Khalifa had made just one mistake, thousands of pipes inside 163 floors could have burst. And not just pipes, a flood of water could have stormed through the entire building. But the real question is, how does water even travel to the top of the tallest building in the world? Burj Khalifa stands at approximately 2,717 feet, so tall that its peak almost touches the clouds. But here is the problem. The higher the building, the harder it becomes to push water upward. And that was the challenge that kept engineers awake. Because Burj Khalifa uses around 250,000 gallons of water every single day, enough for thousands of people. But the question remains, how does that water reach the 163rd floor? The answer is dangerous. A normal person would think, just install one giant pump and push the water all the way up. But that would have been the biggest mistake, because if one single pump pushed water from the ground to the top, the pressure at the bottom could rise to 1,200 psi. And that may sound normal, but an average house pipe can only handle around 40 to 80 psi, meaning the pressure inside Burj Khalifa could tear ordinary pipes apart within seconds. Imagine pipes exploding, walls breaking, floors flooding, and chaos spreading inside the building. But the engineers prevented all of it, and here comes the master plan. They did not treat Burj Khalifa like one building. They treated it like 7 separate buildings. The tower was divided into 7 zones, each around 30 floors, and every zone had its own water tank, its own pump, and its own pressure control, meaning no single pump had to fight all 163 floors at once. It only handled its own section, just like lifting a huge weight by dividing it into smaller parts, making it easier. And that is the secret of Burj Khalifa. Water moves from one zone to the next, from one tank to another, until it finally reaches the top, without a single pipe bursting, without floods, without destruction. This is not just the journey of water, it is the journey of engineering intelligence. But water was not the only problem, because there was a time when its waste had to be carried away in trucks. Yes, a tower like Burj Khalifa once depended on trucks for sewage. But why? When we look at Burj Khalifa, we see glass, steel, and height. But one thing remains hidden, its sewage system. And in reality, it was one of the toughest engineering challenges, because sending water up was difficult, but bringing waste down was even more dangerous. You may think waste naturally falls down, so what is the issue? The problem is speed. Waste falling from 163 floors does not just flow, it accelerates dangerously. And if it kept falling straight down, pipes could burst, joints could break, and the whole system could fail. It would be like throwing a stone from the top of a mountain. The lower it falls, the faster it gets, and the same could happen inside Burj Khalifa. But again, the engineers had a master plan. They used extra-wide sewage pipes, around 24 inches across, almost as wide as a large vehicle tire. But thick pipes alone were not enough. The real genius was collection points placed throughout the building. Their job was to break the speed, control the flow, and keep pressure safe so the waste did not fall all at once. It moved down step by step, and that is what protected the tower. But the real shock came when Burj Khalifa opened in the year 2010. People thought everything was complete, but the truth was, the city's sewage connection was not ready. So where did all the waste go? Every day, dozens of tanker trucks came, collected the waste, and carried it to treatment plants in the desert. Imagine the tallest building in the world running its waste system on trucks. This continued for nearly 5 years, until in the year 2015, it was finally connected to the main city sewage system. This teaches us one important lesson. Building a giant tower is not enough. The entire city beneath it must also be ready. But the next secret is even stranger. In the 50-degree heat of Dubai, why does Burj Khalifa not melt? And how does it make ice at night? To stay cool, you may know Dubai temperatures can hit 50 degrees Celsius. In that kind of heat, steel burns, glass heats up, and even concrete can weaken. So why does Burj Khalifa covered in glass not melt? The answer lies in night ice and a hidden cooling plant. Building the tallest tower in the world is one thing, but keeping it alive in the desert is another battle. Because Burj Khalifa is a giant glass beast, and glass traps heat, meaning if the cooling system failed, the inside could become unbearable in just a few hours. The first problem was direct sunlight. Dubai's sun constantly blasts heat onto the tower, so the 26,000 glass panels on Burj Khalifa are not ordinary. They are heat reflective, designed to bounce heat away before it enters, like a mirror reflecting light. But that alone was not enough, because some heat still gets inside, and cooling 163 floors is a nightmare. So the engineers came up with another master plan. Electricity is cheaper at night and expensive during the day, so why not use cheap night power to defeat daytime heat? And that is exactly what they did. Every night, a special cooling plant creates thousands of tons of ice. Yes, ice. That ice is stored in huge tanks, and during the day, when the sun reaches peak heat, the ice is melted and the cold water from it circulates through the entire air conditioning system, meaning the daytime cooling is actually prepared at night. Outside 50 degrees, inside perfect comfort, outside a desert fire, inside a controlled climate. This is not just engineering, it is mastery over time, money, and physics. But Burj Khalifa's next secret is even crazier. Every day, thousands of people move across 163 floors, and if the elevator system was wrong, the entire building could jam. So how is traffic controlled? If Burj Khalifa had normal lifts, people would be stuck for hours. Thousands of people, 163 floors, and one mistake could freeze the system. Imagine a building with 163 floors and thousands of people moving, some going up, some going down, some to the 20th floor, some to the 120th. If everyone used the same lift system, it would be total chaos, endless waiting and delays. And that was another nightmare for engineers. In normal buildings, lifts are simple: up, down, few floors, done. But in Burj Khalifa, it was impossible, because if one lift stopped on every floor from the ground to the top, one trip alone would take several minutes. So the engineers designed it like a highway system, with fast lanes and local lanes. Burj Khalifa has 57 elevators and 8 escalators, but they are not all the same. Some are express elevators, and some are local elevators. Express lifts go directly to high floors without stopping, again and again. And from there, people switch to local elevators, just like changing roads on a highway. For this, they built 3 sky lobbies on floor 43, 76, and 123. These sky lobbies act like traffic exchange points, where people leave express lifts and transfer to local ones, splitting one long journey into smaller parts. And that is the secret behind the smooth system. These lifts can travel at speeds of around 10 meters per second, meaning you can cross dozens of floors in seconds. This is not just a lift system, it is vertical city traffic engineering. And the final secret of Burj Khalifa may be the most dangerous, because it could have ended the project before it even began. The problem was not steel, it was concrete. And to save it, engineers mixed ice into it. When we look at Burj Khalifa, we only see the height, but the true strength of every giant building lies in its foundation, and the life of the foundation is concrete. But Dubai had one major problem: extreme heat. And that heat was the biggest enemy of Burj Khalifa's base. Because concrete does not harden instantly, it needs time to settle and gain strength. But Dubai's heat could ruin that process. If concrete reacted too fast, cracks could form, and that would be a disaster for the whole building. But there was another danger. The concrete had to be pumped hundreds of feet upward, and if it became too hot, it could start hardening inside the pipes, blocking everything, stopping work, and costing millions. So the engineers created special high-strength concrete grades, C50 and C80, much stronger than normal concrete. But strength alone was not enough. Temperature control was critical, so they added ice into the mix. Yes, ice. As it melted, it lowered the temperature and slowed the reaction, so the concrete would not set too early. But they went even further. The concrete was poured only at night, when temperatures were lower. And this strategy worked so well that Burj Khalifa became home to one of the tallest vertical concrete pumping records in the world, meaning not only the building itself was record-breaking, but even its construction was too. Today, when you look at Burj Khalifa, you see glass and steel, but beneath it lies nights of hard work, ice-cooled concrete, and engineering decisions that turned the impossible into reality. This is not just a building, it is a monument of human intelligence. This was the hidden engineering story of Burj Khalifa: water, sewage, cooling, elevators, and foundation. And if you enjoyed this Zameric video, make sure to like, share, and leave your valuable comments. Thank you for your love and support.